Hi, chemistry students. Welcome to Chapter 5, Measurements and Calculations. Because we're going to be using a lot of measurements in this chapter, you are going to need one of these calculators. Now, I do have some available in the classroom, but if you have a Droid phone, Wabbit, I think that's how you spell it, EMU, let's see, yeah, that should be an I, Wabbit EMU, that's an M, is a free download for an Android phone, and with that you can download one of those. Looks just like that. So that would be one you could use at home. Of course, I'm not going to let you use your phones for a test. I've been told that the iPhone has a version of this, but it costs. If you find something better, let me know. I'm open to new ideas. Measurement is hugely important in chemistry. Measurement describes all of the work that's done in a lab. Every time we have a measurement, you must always first have a number, and then, like 12, and then you have a unit. And this one, make sure you always put a unit at the end of your number. So it's not just 12, or it's not just 12 boogers, it's got to be 12 yards. That is crucial to have a unit at the end. And since we're going to be converting between units, if you don't write the unit, you won't know how to convert. However, the yards, that's a bit of a problem because this entire thing, this system, we're the only ones in the world that uses it. It's called the English system, but I really think it should be called the American system because we're the only ones who use yards or inches or pites or quarts. So I'm sorry, guys, not only do you have to learn how to convert within this system, but you also are going to have to learn the metric system because we're the only ones in the world who doesn't use it. And part of speaking chemistrian is knowing how to use the metric measurements. Before we can get to metric measurements and units and all of that jazz, I just want to review some basic number information. Scientific notation is also called exponential notation. Gosh, I hope I spelled that correctly. Okay, and you've had this in math class before. So you have to take a number like this one, 15 million. When writing all those zeros is a major pain in the butt. So you need to convert that to scientific notation. Or what about this one, 8 trillion? Oh man, that's a pain. Let's see, 8 trillion, I was wrong, 8 billion. Converting that, major pain in the butt to just write out all those zeros. So it would be a lot easier if we could use scientific or exponential notation. To do that then, the decimal point we know, we don't bother to write it most of the time, but we know that that decimal point is way at the end of this number. Well, I need to move this right here. So it becomes 1.5. In exponential notation, this number right here must be a number, a digit between 1 and 9. 0 is not valid. I don't care how many digits you have after the decimal point. We'll discuss significant figures later. But for our particular problem, exponential notation, you take 1.5 times 10. Now I simply count the number of places I move the decimal. 1, 2, 3, 4, 5, 6, 7. So it'd be 1.5 times 10 to the 7th. For this number, well, we know the decimal point's there, and we need to move the it actually exists where it belongs. So if I move this decimal point all the way to here, we need 8. But you can't just write 8. That's not proper exponential, or rather scientific notation. You're going to need at least one other digit there. Times 10. Now we got to count. 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the 9th. So our basic rule for this, if x, which in this case would have been the 15, this number, or this number is greater than 1, we're going to be using a positive exponent. Another way to write scientific notation are for numbers less than 1. For example, we could use these numbers. So again, I need to take this decimal and move it to right there. So we end up with 5.2 times 10, let's see, 1, 2, 3, 4, 5, to the negative fifth. Or this number, we need to move the decimal to right there. So we end up with 3.0, because you've got to have at least that 0, times 10 to the negative 2. So the rule becomes, if the number is less than 1, you need a negative exponent. However, I want to remind you, because most kids seem to forget this, that negative exponent that you see up there, that's a negative 5 or a negative 2, these numbers right here, that negative sign, that actually means division. Honest, it does. Take the number, for example, 2 to the negative 2 power. Well, punch that into your calculators. What do you get? Okay, so once you've punched that number into your calculator, you should get an answer of 0.25. Interesting. Well, the reason I said it means division is this number could be written like this: 1 over 2 squared, which is equal to 1 over 4, which is equal to that number. This negative sign basically means take this number and stick it in a denominator. It does not mean a negative number. This calculator does have some interesting features on it that you should know how to use. And one of the things I want to draw your attention to is this E. There's this little tiny E. Where's my pen? Oh, there it is. There's this little tiny E here, and there's another one there. And I want to show you how these work and what they mean, because using them correctly will eliminate calculator errors. And kids make calculator errors all the time, and I'm trying to help you out so that you aren't one of those. For secondly, to get this E sign, you'll need to use this second button. And then you're going to use the comma button. Now if you look, there's 2 little yellow E's there. So you'll push this and this. That's how you're going to get that E symbol up there. And to do this number, what that means is you're using scientific notation correctly in your calculator. So if I look up here, we have 4.58 times 10 to the 4th power. But to enter that in your calculator, you'll use 4.58, then this second button, then this button, so your calculator will say E4. These two things mean exactly the same thing. The reason it's important to enter it this way instead of that way is your calculator will see this all as one term and keep it together. If you enter it in the top way, your calculator sees this as one term, this is a second term, and your order of operations doesn't always come out so nicely. When using scientific notation, do not use this caret button at all. I mean, if you're taking just any number and saying, you know, okay, I got to cube this number, go for it, use it, but not for scientific notation. And make sure that you're using this button down here for negative numbers. Okay, so into your scientific calculators, I'd like you to enter that very first number just as it's written. So we have 1.5 times 10, and here, go ahead and use the caret. So you'll put all of this into your calculator just as is. 1.5 times 10, negative 3. Then divided by 7.5 times 10, use the caret, 5. Pause the video, punch that into your calculator. Yeah, you should have gotten 20. Does that make sense? I mean, let's think about it logically. Cross these numbers off for a minute. So the problem basically becomes 10 to the negative third divided by 10 to the fifth. And when the bases are the same, do you remember what we can do to the exponents? If you said subtract, you're right. So we have -3 minus 5. That equals -8. So your final answer should be somewhere in the ballpark of 10 to the -8th. Does that do it? Not at all. Your calculator completely messed up the order of operations. So let's try entering it in our calculator as this: 1.5e -3, that's not a minus sign, that's a negative sign, divided by 7.5e5. Your calculator now sees this as one term and this is one term. And yes, 2 times 10 to the -9th is in the ballpark that we had guessed. Do not write it like that. That is not an acceptable way to write an answer on your paper. This is what I call, math geek speak. It's like, the data you would have to enter into a calculator. But this is the way we actually write it.